Yeah. So my name is Tim Sacco. I'm a sociologist by training and a postdoc at NSF's Noir Lab. I'm working on the U.S. Extremely Large Telescope Program's Research Inclusion Initiative. And I'll be talking about that a little bit at the end of my talk. So Astro 2020, the most recent decadal survey, outlined research inclusion as a key priority of the astronomical community in the coming decade. The decadal reported that up until now, many of the gains on diversity or equity in astronomy have been made in the education sector or in academic departments, but argued that more improvements are needed in the research sector. We're seeing the introduction of inclusion plans as part of proposals for funding our telescope time as one strategy for addressing the need to improve DEI efforts in research contexts. So today I'm going to be discussing how prepared the astronomical community is to draft research inclusion plans, how prepared the astronomical community is to evaluate inclusion plans, and also promote a tool that I'm currently working on via USELTP's Research Inclusion Initiative that will contribute to preparing the astronomical community to undertaking these tasks in the future. So in addressing these questions, Dara Norman and I recently analyzed a newly required inclusion plan by NASA's Astrophysics Theory program. In support of NASA's core value of inclusion, NASA piloted the addition of a 1 to 2 page inclusion plan alongside research and data management plans. For inclusion proposals, PIs were to develop 1, plans for creating a positive and inclusive working environment for those carrying out the proposed investigation, and 2, plans for how the project would contribute to the training and development of a diverse and inclusive scientific workforce. Otherwise, NASA's prompt was largely directionless, as they didn't want PIs to just regurgitate back what they thought NASA wanted to hear for their inclusion plans. So for our review, NASA charged us with analyzing the distribution of key themes that were presented by proposal PIs across inclusion plans, and also with analyzing reviews of these inclusion plans, which gave us the opportunity to explore how different reviewers assess these proposals. Thus, these data provided a useful window into how prepared the astronomical community is to develop and assess meaningful inclusion plans going forward. So NASA provided us with 120 inclusion plans total. These inclusion plans were reviewed by 2 sets of reviewers. The first was a panel of diversity, equity, and inclusion experts, and the second was a panel of science reviewers. So first, with the DEI expert reviewers, NASA provided the DEI expert panel reviews for all 120 proposals, as well as the distribution of scores provided by the DEI expert reviewers. So in this figure, the blue line shows the distribution of the 120 reviews of inclusion plans by DEI experts and by score that they received. As is evident here, the DEI expert reviewers found inclusion plans were mostly marginal, I guess, with the distribution of scores peaking between good and fair. More proposals received scores on the lower end of the ranking, with very few in the excellent or excellent-very good rankings. For the science panel reviews, NASA could only provide us with a small sample of science panel reviews due to the time frame by which they wanted us to produce our initial report. We're going to be writing a more in-depth one later this summer, so be on the lookout for that. We requested a subsample of science reviews for 32 proposals that roughly match the distribution of the DEI expert scores that we had. This figure shows a comparison of the distribution of 120 proposal scores with the 32 proposals from which we sampled, the orange line here. For science reviews, we had proposal numbers, but we didn't have actual scores because NASA didn't ask the science panel to provide letter grades on account of this being a first-round experiment to start. So it's an imperfect comparison, but it's how we managed to do it for this paper. We focused our sample on science reviews around plans that DEI experts rated good, good-fair, or fair, which reflects our interest in understanding how the community of astronomers assessed inclusion plans that DEI experts found to be marginal or inadequate. So this table shows several themes that arose across the inclusion plans. Today, I'm going to be talking about DEI credentialing, fostering an inclusive environment, and cross-institutional partnerships. and how they were reviewed by DEI experts and science panel reviewers. So first, the theme of DEI credentialing. PIs often outline their personal histories with equity and inclusion efforts. The PIs of more than half of the inclusion proposals, 64 out of 120, attempted to outline their DEI credentials to give validity to their project. 44 out of 120 highlighted the PI's history with DEI to signal that the inclusion plan would likely work when they carried it out. It was also common for proposals to outline the institutional credentials of the environment in which projects are embedded. So for instance, 30 out of 120 proposals detailed institutional efforts at the university level to credential the project, while 22 out of 120 outlined department level credentials. So for instance, one proposal reported that its host department had recently eliminated the GRE requirement for graduate students. This had broadened the pool of graduate applicants to the department, which in turn would shape the diversity of recruitment for the project. Another proposal detailed a department diversity and inclusion working group as helping to shape the environment in which projects would be conducted. DEI credentialing was not necessarily associated with a high or low ranking. So for instance, one proposal that was ranked fair-poor reports that a PI's history of lecturing in summer schools with diverse students, and another ranked fair reports a PI's history of including diverse undergraduate and graduate students on a research project. In highly ranked proposals, neither DEI expert panel reviewers nor science panel reviewers mentioned when a proposer detailed their DEI credentials, and instead used the space to highlight the strengths and weaknesses of the concrete plans that were being proposed. DEI expert panel reviewers and science panel reviewers describe DEI credentialing of slightly lower ranked proposals, those in the very good, good, or good-fair range, as a positive. So for instance, science panel reviewers lauded one proposal ranked very good because the PI had a history of mentoring women and people of color as a major strength of the project. In some lower ranked proposals, DEI experts critiqued how a PI discussed their DEI credentials. So for instance, in one proposal ranked fair, DEI expert reviewers noted the PI's history with inclusion efforts as a strength of the project, but also wrote that the plan didn't clearly state how the diversity and inclusion activities of the PI would be an integral part of the way in which the proposed research was going to be accomplished. In another example, DEI inclusion panel reviewers looked favorably on a good-fair ranked proposal because of the PI's history with DEI work in the American Physical Society, but then critiqued the proposal for a lack of discussion about how the resources from this network would be used to guide programming efforts. The best proposals connected PI's past DEI experiences to how they had thought through the details of their inclusion plans. Looking at how DEI experts and science panels differed in their interpretation of a PI's attempt at credentialing was a fruitful point of comparison and understanding differences in reviewers. So for instance, this is just one example, a PI reported their history working with quote unquote emotional or mentally disabled students, and they had wrote that their experience had made them realize that such students were disfavored by informal weekly meetings between students and PIs. The science panel reviewers latched onto this language, writing the PI mentions working with quote unquote emotional or mentally disabled students as being possibly disfavored by an informal weekly meeting. But the PI didn't provide any evidence to support that statement, and also that many other types of students may be disfavored by these informal weekly meetings as well. In contrast, the DEI expert reviewers also latched onto this phrase, but in a different way. The DEI expert panel wrote that how the PI had chosen to describe their students as quote unquote emotional or mentally disabled in their credentialing efforts had given the panel pause, and that this characterization of students had undermined the inclusivity goals that the proposal was trying to promote altogether. Here, the science panel and expert inclusion panel reviewers singled out the same phrase, both listing the PI's characterization of students as a weakness, but there are differences. The science panel reviewers wanted more inclusive language and that informal meetings may be detrimental to more students than those that were specifically singled out in the proposal, while the DEI expert reviewers raised concerns over the tone of the language and its implications for inclusivity on the project more broadly. This example highlights how DEI experts and science panel reviewers highlighted similar themes in their reviews, but interpreted them differently. So moving on, a key component of NASA's call was how proposals would create and sustain a positive and inclusive working environment for the research team. 84 out of 120 proposals attempted to describe how they would foster an inclusive environment for the research team. One of the most common strategies for creating an inclusive team environment put forth by PIs was adopting formal codes of conduct that would guide team meetings and interactions. 22 proposals sought to establish a formal code of conduct. This figure highlights the distribution of plans that propose some sort of code of conduct in relation to overall score distributions of inclusion proposals. This figure shows that proposed codes of conduct are pretty evenly distributed across scores, mirroring the broader score distribution of proposals overall. Both science and expert inclusion panels noted that the planned code of conduct in one very good proposal is a strength to fostering an inclusive environment. But then the DEI expert panel also wrote that the proposal didn't adequately explain how a code of conduct would create a more inclusive environment. Again, DEI expert panel reviewers and science panel reviewers focused on different aspects of the same details or themes presented in proposals. Another common strategy for fostering an inclusive team environment was plans to mentor students or postdocs. 27 proposals put forth some sort of mentoring plan as a strategy for fostering an inclusive environment. Most of these were normal mentoring practices that would be expected of PI and student relationships, even when an inclusion plan was not required, such as helping students publish, expecting them to attend conferences or present at conferences, or expecting or helping students expand their professional networks. What these numbers show around mentoring or code of conduct is that without guidance, proposers will take the path of least resistance. They'll propose easy plans, which are not necessarily conducive to increasing equity or inclusion in the research sector. Fewer proposals, only 12, put forth a plan to evaluate the inclusivity of the environment. This figure shows the distribution of plans that proposed evaluations of the working environment compared to the total distribution of inclusion proposals by rank. The plot shows that low-ranked inclusion plans, those ranked fair, fair-poor, or poor, did not propose any kind of evaluations. Looking more closely at the 12 proposals that did propose evaluations, only 1/3 of them, 4 out of 12, are actual substantive plans, meaning they detailed how evaluations would take place rather than just stating that evaluations would take place. So for instance, one proposal ranked excellent-very good, planned to assemble an inclusion advisory and evaluation committee that would meet the project team with and without the PI once a semester, conduct a written survey of all team members, and write an annual inclusion evaluation report that would be included in the annual progress reports to NASA. Both science and expert inclusion panel reviewers noted the evaluation plan as a major strength of the proposal. The only weakness given in regard to the plan was by DEI expert panelists who wanted more detail about whether there was a precedent for such a committee at the PI's home institution and how the committee would be established in practice. In contrast to the adoption of codes of conduct or normal mentoring practices, it's difficult to enact a proper evaluation plan of a project or a program. The fact that few proposals tried to enact evaluations suggests this is the case, and neither DEI expert reviewers nor science panel reviewers automatically interpreted evaluations as adequate. It's worth noting, however, that evaluation plans still show a more narrow range of rankings than those that proposed only a code of conduct or mentoring practices. So another strategy for broadening participation of underrepresented researchers is fostering cross-institutional partnerships between small and underserved institution scholars and astronomers at research universities. In recent years, federal agencies like the NSF have championed cross-institutional partnerships as an effective strategy for increasing participation of underrepresented groups across STEM disciplines. Out of 120 proposals, only 13 discuss cross-institutional partnerships in relation to their project. 8 of these discuss cross-institutional partnerships in a credentialing kind of way. For instance, one proposal noted the project would take place in a department that's working with a bridge program. Another notes that COIs located at another institution had a past history of recruiting underrepresented minority students onto projects. We differentiate these credentialing proposals from 5 of the 13 proposals to discuss cross-institutional partnerships with plans to leverage the partnerships as a strategy for achieving diversity, equity, and inclusion. This figure highlights the distribution of all proposals to discuss cross-institutional partnerships with those that had a plan to leverage them. For instance, a good-fair proposal commits to recruiting the students that will work on the project from a minority serving institution via a bridge program. A proposal ranked very good-good planned to leverage the fact that the project spans multiple institutions for mentorship purposes by requiring students on the project had an external member or external mentor at one of the other institutions. And a good proposal reported that a project is part of a multi-institutional collaboration that includes an HBCU and is affiliated with a pair program, writing that funding the research proposed will provide opportunities for underrepresented minorities to collaborate on the project. Cross-institutional partnerships are rarely mentioned. Only about 11% of the proposals mention them. And as with other themes discussed today, a team didn't necessarily do well just because they attempted to leverage cross-institutional partnerships. There's teams out there that are attempting to do the right thing and promote good practices, but are not uniformly doing a good job with it. So before I move on to talking about the tool that we're developing at NORLab, I want to do a summary of the report. The proposed inclusion plans submitted by PIs were found to be mostly marginal or inadequate as reviewed by DEI expert panels, with more distribution of scores peaking around good or fair. More proposals received scores on the lower end of the ranking, with very few in the top rankings. This demonstrates a need for the astronomy community for resources or training to help PIs understand what makes for a very good or excellent proposal. Given the very general nature of the NASA proposal instructions, PIs tended to focus on themes or activities around topics that are easiest to execute, like codes of conduct, not necessarily those themes that would lead to the best advances in inclusion for the team or department, like evaluating the inclusivity of the environment. In credentialing one's own individual experiences with DEI, or that of one's department or university, was a popular theme. However, credentialing alone was not sufficient for the plan to be ranked highly, and proposers needed to demonstrate how past experiences qualified the proposer to do well with current plans. The best proposals connected PI's past DEI experiences with how they had thought through the details of their research inclusion plan. And in comparing reviews, we anticipated there were going to be greater differences between the science and expert inclusion panel reviewers, but the science panels often match the overall sentiment expressed in reviews provided by DEI expert panels. However, each group honed in on different elements of the proposal to question and critique, with the DEI expert panel probing questions and concerns with more detail. For instance, while both science and expert inclusion panel reviewers celebrated proposals that leveraged institutional resources for DEI goals, the expert inclusion reviewers sought more clarity on how institutional resources would be leveraged or connected to a project. And generally, the DEI expert panel reviews were more detailed in their evaluation of proposal strengths and weaknesses than the reviews provided by the science panel. These findings suggest that we need interventions aimed at ensuring expertise on research inclusion is available to the reviewers of research inclusion plans as well. Otherwise, reviewers may be asking the wrong questions and determining the potential of an inclusion plan to promote equity on a team. So now moving on for the last couple minutes to a project that I'm working on through NORLab. Like I said, I am a postdoc working for the US Extremely Large Telescope Program. US ELTP is a joint initiative to provide the entire US astronomical community with access to the Giant Magellan Telescope in the Southern Hemisphere and the 30-meter telescope in the Northern Hemisphere. The goal of US ELTP is to provide US scientists at least 25% of the observing time on each telescope through an open peer review process facilitated by NSF's NOIR lab. So through US ELTP, observing proposals are going to be required to include a research inclusion plan to apply for telescope time. However, our analysis from the NASA inclusion plans show that astronomers are not necessarily expert at writing or reviewing adequate research inclusion plans. Thus, a major deliverable of US ELTP's research inclusion initiative is going to be a toolkit of collaborative practice, which will provide the community with a framework for what needs to go into a research inclusion proposal. The toolkit will provide examples of good practices for research collaboration that embody the concept of mutually beneficial partnerships. So it'll discuss themes like DEI governance, recruitment, collaboration, communication, or cross-institutional partnerships. The Research Inclusion Toolkit is also going to provide metrics or rubrics to assess the efficacy of different collaborative practices. So for instance, we're developing a rubric that highlights the differences between a subpar and really good mentoring program for early career researchers, and another rubric that highlights subpar versus really good recruiting practices for hiring graduate students or postdocs from a diverse pool of candidates. The Research Inclusion Toolkit will benefit proposers by making clear the metrics by which astronomers are being measured. This will give them the tools to develop good, meaningful inclusion plans for their project. By making expectations clear, it gives them the opportunity to rise to the occasion and develop good plans. This toolkit will also benefit reviewers by providing recommendations and guidelines for how to assess the inclusivity of research proposals. We at USELTP's Research Inclusion Initiative are envisioning this toolkit being accessible to the broad astronomical community external to USELTP. We hope it will provide guidance on research inclusion plans broadly and not just on the ones being submitted for USELTP telescope time. So I'm going to briefly discuss how we're thinking about this being laid out in the last couple of minutes here. It's still in early development. I wish I had more to show you. But we envision the toolkit's going to be hosted on a website. An astronomer will log on. It'll have these initial questions that we're going to answer in the front end introduction before they dive deeper into the specifics of the toolkit. So users will come in, they'll read about the toolkit in relation to USELTP's research inclusion plans, then either explore by diving into one of these boxes here at the bottom, or by using a filter to reach more specific or tailored information. So I'm going to very briefly cover a little bit about each strategy. So first, drilling down, say for instance, they come in, they select this section, I want to explore considerations for assembling a diverse team. We're imagining this is going to have a section on team diversity, outlining the different kinds of diversity to consider in research collaboration. So for instance, with demographic diversity, it'll provide best practices for teams that are diverse by axes of identity, like race, gender, ethnicity, or disability. For instance, it'll provide recommendations for preventing underrepresented groups taking on token status on a team. When underrepresented groups become tokens, they're more visible on teams. This sometimes leads to opportunities, but it also can lead to more work or harsher evaluation by colleagues. These recommendations will highlight how to integrate different identities onto the team rather than just boosting their representation. It'll also discuss disciplinary diversity or interdisciplinarity. So in relation to astronomy, how different astronomical researchers might work with the same data set in different ways or ask different questions of the same data, and the challenges that might arise from having different languages or ways of thinking about the research they're doing. It'll have a section on recruitment. So I imagine most hiring in relation to USELTP or inclusion plans will be with graduate students or postdocs. So it'll outline what kinds of practices limit or expand recruitment, such as recruiting at meetings for underrepresented groups as boosting recruitment, not relying on PIs, pre-existing social networks, or hiring decisions, and how the language of a job ad can limit recruitment for a position. And then very briefly, Proposers are also going to be able to filter what information they're looking for based on the plans that they're trying to enact in their own project. So we envision this will take the form of a page with a drop-down menu in which proposers can sort by topic, themes, audience, and resources. For instance, they might be looking for, they want to focus on professional culture activities, specifically mentoring junior faculty. They may want to find metrics that show these mentoring activities are working. Or there will be other options that they can filter as well, as this slide shows. So this layout will help PIs find the right information based on the plans that they're developing. And we're going to be adding more topics to these sections inductively based on the resources that we are reading on equitable collaboration as we design the toolkit. So yeah, I know I'm a little over time, so thank you. I appreciate it, and I look forward to any questions you have.
Thank you, Tim. Let's open it up for questions. Any questions? Federica.
Thank you so much. I just have no words to say how important and well and overdue actually this is. I think there have been like such a long history of asking us to talk about how we implement DEI without asking us to really get knowledgeable about what we're going to say. And so related to that, I think that it's important there is also like space for PIs and proposers to outline that they want to learn and that they want to advance their knowledge to do better. And how much influence can we put on the agencies to make sure that that is itself a thing that is welcome? Perhaps, you know, a DEI plan cannot rely entirely on that. Of course, you also have to demonstrate that you're doing actionable, that you have actionable items. But that there is enough space for the PIs to learn, because it takes a long time to learn these things.
Yeah, I definitely agree. I certainly think that we need to allow space for, I guess, the community to recognize where change is needed and where improvements can be made. And I guess just at least acknowledging and rewarding that people are willing to come to the table and admit where there might be weaknesses in their plan. We're hoping that the toolkit will help people, I guess, educate themselves before writing proposals. The toolkit is still a few years out, and so we recognize that this isn't like an immediate service that's being offered right now. But we're hoping that the service that it will provide will allow people to do some of that educating of themselves and improving their knowledge about DEI before developing inclusion plans.
Thank you.
Hi, Tim. I just want to echo, thank you so much. This was such a clear and helpful talk. On the toolkit, I'm wondering, is there any plan to provide, so this sounds like just a very wonderful set of detailed guidelines for best practices recommended by the experts. I'm wondering if a PI wants to expand some of these practices, will there be a place to interact with those experts to workshop some ideas? Or should that be done on a more local scale in your mind?
So that's something that we've like very briefly thought of, but haven't really figured out how that will happen. But I do think that's a really great idea, especially as the astronomy community starts participating more in or incorporating more DEI efforts into research proposals. I imagine that there's going to be new knowledge that's generated specifically to the case of astronomy. A lot of the sources and things that we're drawing on are coming from other STEM disciplines as we design this. And so I think it would be a really great idea and a great service to incorporate a way for astronomers to, I guess, both give recommendations as they engage with the toolkit, but also kind of report back what's working and not working among their own teams. So yeah, I don't know if that answers your question, but I think it's a really great idea.
And Jenna, for the final question.
This is actually a response to Ashley. So it was mentioned earlier that one part of LINC is the LSSTC Catalyst Fellowship. And part of that fellowship involves a team of senior social science researchers. And so our goal, part of our goal with that program is not only to follow best practices, but to push the boundary and figure out what best practices should be. And so we will be also selecting not only astrophysics postdocs, but several social science fellows. And both those fellows and the senior social science researchers associated with the Catalyst program will be doing surveys of the LSST research community, and also providing opportunities if anybody wants to get involved with their research and at very least participate in trying to answer exactly that question. So LINC is interested in not just following existing best practices, but trying to assess them, expand them, and figure out what really works.
Thanks, Jenna.
Thank you. And let's thank Tim again for this excellent talk. And we'll finish this session with Andy walking us through an example science use case to get a feel for what we're expected to do essentially over the next day and a half.
So it's not just going to be me, excuse me, Rachel and I are going to try and walk you through how to think about the use cases, and then also what's the facilitation plan for this afternoon as we start coming together with the writing these use cases. Excuse me. So I just wanted to point you to where all of the various repositories are. So many of you have already seen this. If this is new to you, this just shows you the repository where we have the example use case for finding RLIRE catalogs, and then a couple of templates which are technical cases and science cases. Technical cases we'll talk about next time. Think about technical cases as software or infrastructure that can cross multiple science areas. An example of this would be clearly something like photometric redshifts, right? So how do I develop photometric redshifts is a wonderful technical case because it hits many science applications that we're interested in. And then we have the template here for the science cases. I'll go through this template in a little bit more detail. Thank you for everyone who has put these in. If you want to, you can move your use cases. So I will show you where to move them to. Thank you for everyone who asked to remove the various templates when they realized that we did not give you permission to delete stuff. And that was deliberate, not because we don't believe that you should have the ability to delete things. It's just that we didn't want you deleting things by mistake. So that would have made for an awkward workshop. So if you take one of the templates, say the science use case template, you can copy that, you can fill it out, and then you can go to the science use case repository, and you can see here are all of the different possible places where you can place that use case. Don't stress about which is the right one for you. Put it into one of them. You can move it at another time. If it turns out in particular that you want to move it to a technical use case, that's fine. We're just trying to get an initial structure so that we can organize the discussions this afternoon. Thank you for putting together data science. And I actually extended that to technical use cases, so that we could collect those in the same place. Okay. Okay, so that's where we like the use cases to go. What I'm going to do is just walk you through what we're trying to get from these use cases. This is not to tell you how to write it. There are many different ways to write it. What I'm trying to really do here is to give you some ideas about the questions you should be thinking about when you're writing the use case. So The main one is to start saying what is the science, and I'm going to drill down into more detail here as we go through the slides. So what is the science? Think about it as a science abstract. If everything went perfectly, what is the science abstract that you would write 2 years from now with LSST data, with the discovery that you're making? Then what we'd like to know is a little bit about why this is ideal for LSST. Why can't we do this with our own data today using, say, dark energy survey data in terms of the constraints that you can get out of it? What makes it something that's ideal for LSST? And then coming back to what we want to do in terms of turning this into software infrastructure, why can't you use today's tools? So what is it about the tools that you have today that don't quite work at the level of LSST? Because again, with Link, there's limited resources. We're really trying to find the gaps. But if you can work with the Rubin Science platform, and that's ideal for you and it gets your science done, that's fantastic. If there's other resources that you need in terms of software infrastructure, that's what we're trying to capture here, and then to look how it crosses the different science areas. So essentially thinking, what keeps you up at night thinking about how am I going to do my science with Rubin in terms of the computational challenges? And then one of the most important things here is how are you actually going to undertake your project? So what is the analysis workflow, and how does that map to the different software algorithms you want to actually use? And that allows us to take these science use cases and look at what's the commonality in terms of the software that needs to be implemented, and then look at the commonality between different science cases across all of the different science collaborations that Fed was talking about. And as I said at the beginning, what we really want to do is to focus on the first 2 years. So if you need to do integrated depth to 10-year depth covering 15,000 square degrees of the sky, write that use case, but note that in the actual in the use case itself that you need, this is a kind of a 10-year project. We're going to try and look at what the infrastructure is for the first couple of years of science, because we'll learn a lot about how we work with Rubin in the first couple of years. Okay. So this is what the layout of the use case looks like. I'm going to drill down into 3 areas in detail: the challenges, the analysis workflow, and the software capabilities. But just to quickly run through the other topics, we have a title, something descriptive about what the science is. We have an author. We'd really like to make sure that we give credit as we're writing this white paper, and to make sure that people who are contributing to this contribute to the white paper itself, so that you get credit for the work that we're all going to be doing in this workshop, and also to allow us to follow up to make sure that you're engaged in the process as we think about the science. As we think about the software that is needed to make sure that that maps onto your science. Just the date, so we know when it was last edited. The abstract I mentioned before, just an abstract of what you're going to be discovering. Science objectives, if there are a set of milestones that you have to hit. For example, if you're working with alert data, maybe you have to do classification of periodic variables before you can identify RR Lyrae stars, before you can actually measure metallicity, before you can do your science, which might be the metallicity distribution within the Milky Way. Then we get to the challenges. What makes this hard? Why can't you do it with existing tools today? And the next 2 are running on LSST data sets. So are you going to be working with the alert stream? Are you going to be working with the data that is part of the data production pipelines? And then also, what data exists today that you could use to validate these algorithms in this infrastructure, and potentially do science as we prepare for Rubin as it goes through the final stages of construction and commissioning. And then the main ones that I'm going to touch on in detail here are kind of the analysis workflow and the software capabilities. And then references are super helpful in terms of giving a background to the science or a background to the software tools that you want to use. Okay. So I'll touch on 3 things: challenges, and then kind of science or software analysis workflow. And again, all we're trying to do here is to give you some questions to help you think through what to put down in the challenges. So these challenges could be technical challenges, they could be algorithmic, it could be that A technical challenge could be I need to run it on 1 billion sources, and it takes me 10 minutes to run on an individual source. How am I actually going to manage to have that run across large data sets? Algorithmic challenges could be I just don't have an algorithm to identify these sources, and we need to think about how to create that. Scientific challenges could be we don't have models, right? So the models for the spectral energy distributions don't have sufficient fidelity for the quality of data that are going to come from Rubin. Or it could be logistical. We need to follow up these classifications with 10-meter class telescope, and that puts constraints on us in terms of our false positive rate that we can actually manage. We'd like to know a little bit about what impacts you in terms of the science relative to the quality of the LSST data. So how accurately does the astrometry have to be, or the photometry? We'd like to know about how often these analyses will be run. If it's with maybe you'll run it every month as a new data set comes in. Maybe you run it once a year. Maybe you run it every couple of years. And so we'd like to get a sense of how often this process is going to be run. And then if there are any kind of important urgent time constraints, right? So I need to be able to do spectroscopic follow-up within 5 days of the detection of a transient, and that means I have to be able to do the classification. I need to be able to do this in terms of I can only really afford to have a false positive rate of a few percent, otherwise the telescope allocation committee is never going to give me more than one allocation, because I'm not going to actually detect the objects I'm looking for. So trying to understand what are those time constraints. The analysis workflow, we want to provide essentially a step-by-step process about how you're going to work through analyzing these data. So an example of this, when I was writing down the R.R. Lyry case, the first thing that I wanted to do was to identify objects that had at least 10 observations within the first 6 months of LSST data taking, because I thought that would give me good time series data. Then I wanted to filter out low signal to noise detections. I wanted to get rid of objects that had a fairly, the sampling in time space was not ideal for actually measuring periods. Then I wanted to be able to identify which were variable sources. From their colors, I know potential R.R. Lyry stars. Then I wanted to go through and measure periods and so on. And so as you work through those different steps, we'd like to get a sense of, as you go through those different steps, are there other intermediate data sets that you're going to be generating, right? If I'm classifying variable sources, do I want to annotate a database that says, this is my classification, this is the probability of that classification. Maybe that probability isn't just a number, maybe it's a probability distribution. And every time I get more data, does that change my classifications? So we'd like to get a sense of what are the intermediate data sets that we're going to be generating, and how are you going to be accessing these multiple times? Maybe you're going to be sharing these with the rest of the community. And then the types of analysis techniques or software packages, if there are specific packages that you are using or that would be useful for this, noting those would be extremely helpful. Then we get down to the kind of the drilling down again to the next level in terms of the capabilities of the software. Are there new algorithms we need to develop? Are there modifications to those algorithms? If there are existing software packages, do they need to be scaled up to the data volumes? Are they too slow? Is it hard for you to manage the distribution of these algorithms across lots of computers? How big are the data sets that you're working with, and how slow are the current approaches how you would do this analysis today? And then something at the end that we often gloss over, but in reality, in terms of data exploration, is one of the most important sets of tools that we use all the time, and that is visualization. So that could be visualization of the outputs. It could also be visualization of how you debug the system, because we're all going to do a lot of that in the first couple of years, whether it's on the software themselves, or whether it's going to be on the data. So that is trying to give you an overview of the sorts of questions. There's more detail in the template. You don't have to answer all of those questions. It's just to try to provide you with some guidance on the narrative. If you don't know the answers, don't worry about it. Just write in that nobody knows or we don't know the answer to this question. It's an open question. We're not looking for something that is perfect by the end of this workshop. We're trying to get some of the details so we really capture we capture the science and we capture the challenges that you're facing to do the science. I'm going to switch it over to Rachel, who's going to tell us about how we're actually running these breakouts.
So I get to tell you how all of this is going to work in the afternoon. And I realize I am the person who's standing between all of you and lunch. So I will try to take about 10 minutes and then we'll have a few minutes for questions here. Okay, so I'm going to start with the science breakouts. So that's this afternoon. And then there's another set of science breakouts tomorrow morning. We're going to split up into 7 groups that are associated with broad scientific areas. And I know a lot of people work in multiple areas or at the interface between areas. That's fine. Pick one, go where you're comfortable. If the groups are like really imbalanced in terms of numbers, we might ask you to shift around to something else that you're similarly comfortable with. And I'll show the groups, the areas on the next slide. So each of those groups is going to have an overall facilitator and a Zoom facilitator to support people participating virtually, and a Google Drive folder to capture their work. So those are the folders for the science areas that Andy showed earlier when he was walking through the Google Drive. As an aside, I would say if you're looking for those links, you can find them in some of the participant communications that went out in the past week. If you use those communications to get into the Slack channel, the Google Drive folder is also bookmarked in that channel. And if you still don't know where to find it, you can come find one of us during lunch or something. We can point you to the right place. Okay, so there's a single Zoom meeting being used for the breakouts, so that those who are participating in the full workshop virtually have gotten the link to that, and they'll be able to go into whichever of they'll be able to choose their own breakout room corresponding to the science area. So the breakout areas are here. There's cosmology, solar system, 3 extragalactic split across static, variable, and transient, and 2 local universe split across static versus transient and variable. These were meant to give similar group sizes between in-person and virtual participants, on average about 10 each. There's an overall facilitator listed and someone who's going to be paying attention to Zoom listed here. And you can see there are locations. So for 2 of them, cosmology and extragalactic static science, there are locations on the 5th floor listed. Everything else says 2nd floor promenade. So on the 2nd floor promenade, there are these whiteboards that are going to be used to help people identify the locations for the different breakouts. I actually want to ask if Katie or Adrian has anything else to say about the locations, anything else that people need to know at this point.
Yeah, I don't think so. So you can take the elevator.
Use your seat mic, please.
Here. Anyway, take the elevator or the stairs up to the 5th floor. Out of the elevators, the classroom will be straight ahead and to the left, next to the kitchen. And out of the elevators, the conference room is down the hall to your right. So there's no arrows or signs, but the rooms have signs on them that say either classroom or conference room. I think that's all to say.
Thank you. Okay, so we have these breakout areas. Like I said, you can pick one that matches your interests. We might shift around a little bit if they're super imbalanced. And if you're feeling horribly torn, do remember there's another science breakout tomorrow morning. So you could pick one today and another one tomorrow if that works best for you. So in terms of how that's going to work, so those breakouts are going to start at 1 p.m. after lunch and go until 4 p.m., after which point we'll have an hour for reporting out. Okay, so this is about what's happening from 1 to 4 p.m. Okay, so the first thing is everybody is going to go to the breakout they wish to attend. And we'll also be enabling some virtual participation. We might rebalance the groups a little bit at that point. And everybody inside of the breakout is going to introduce themselves using their slide in the interdeck. So if you didn't put a slide in there, maybe do that during lunch. And then the participants will be asked by the facilitator to brainstorm specific science use cases within that broad area that they may wish to flesh out during the course of the session. And so that could be based on their own ideas or drafts that they've already put in the Google Drive. And so people can pair up to kind of brainstorm. The facilitator will then get all the participants to come together to pitch those ideas because different people may have had similar ideas. And the group will prioritize and come up with a plan to develop science use cases. Some of the ones that were pitched following the template, or if there are already drafts, people can work together to update the existing drafts. And so this is probably best done in groups of 2 to 4 people. So with a typical science area having like 10 people, there'll be a few groups working together within each one. And then the bulk of the time will be spent working on the use cases following the template. There is a coffee break, and the time when coffee is available is listed on the schedule. So don't forget to take a break, whether for coffee or otherwise, if you're running out of steam. But 20 minutes before the end of the session, so around 3:40, the group should start filling in the template report out slides, which is a single slide deck, again, within the same Google Drive. And it has some templates for the report out so everybody can copy and make a slide for their use case. However, given the timing for the report out, and that we don't have infinite time, we'll ask that if a given science area has more than 2 use cases, they should work together to down select among them and present a subset. Of course, the drafts of the use cases are still in the drive, so people can still refer to other ones, but just pick 2 representative ones to present at the report out, and make sure that there's a spokesperson who's prepared to speak to the slide for each one during the report out. So that's what we're going to do today in the breakout session from 1 to 4 p.m. and then report out together from 4 to 5 p.m. And that's all I was going to say about how these sessions work, but I'm happy to take questions.
Maybe a question and comment. So we may not present all the use cases, but I think we intend to include them all in a white paper at the end, right? So they will not be discarded or something. They'll all get used eventually. All text will be looked at.
Yeah, that's the plan, and that's why all of them will be in the folder, and the names of the people who developed them will be there so that you know who to reach out to, even if they didn't present it. The other thing to keep in mind is that we have a second science breakout tomorrow, so it could be that that'll be spent developing new ideas, but it could also be spent further developing ideas that were pitched today, and then maybe some of the ones that weren't presented today could be presented tomorrow.
There's a bit of a follow-up question on Zoom, which is, can people add incomplete and work in progress documents and modify it in the coming days after the workshop? And so they're specifically asking about a final deadline for that.
So I want to say definitely big thumbs up to adding incomplete ones and working on them. I personally did that myself. I added one and I didn't have time to fill stuff in. I figured that's the whole point of working together. Good question about a deadline. We don't want things to drag on forever. And and if you say we're going to do this in a few months, then it's easy to lose momentum. So I mean, spitballing, it would be good to try to clean things up like during this week or so that we can follow up with people afterwards. I don't know if anybody else who's been involved in organizing wants to add or modify that, because I did just.
I guess at some point we said we might convert this to like a white paper document. At some point it will become therefore a tech file, and you shouldn't update the Google. Maybe we can agree that right now, if we're moving something over, we could put a comment at the top of the file or in the name of it saying it's moved, and that will be the point in time when you really ought not to update it anymore because it will be lost.
Yeah, that's a good point. I should also say that, I mean, we do plan to have follow-up communication with people saying, okay, things are now moving into the LaTeX, here's where you can find it, and so on. So it's not going to be like a mystery when this is happening. We'll signal on the docs and we'll signal in the Slack channel and follow-up email communications. Mario.
I think a safe timeline to think of is by the end of this week for if you want to change anything in the Google Docs. And then when we start moving things into kind of collaborative overleaf type environment, there'll still be a lot of time for people to go in, make edits, make suggestions. We want to really turn this into a collaborative white paper writing process, but try to focus to get things in this week.
I don't know how this works, but is that for tomorrow, the Science Case 2 breakout session is going to have the same groups?
So tomorrow morning's breakout, the science breakouts will have the same 7 areas. But if you like really want to contribute to a different area, you can switch and go to a different one tomorrow.
Yeah, I'm just thinking like if there some other ideas come up during the discussion and I might propose new use cases, it can still be discussed like tomorrow.
Oh, definitely. Yeah. So what we're anticipating will happen is, during this initial step 3 brainstorming, right? It could be that the group will come up with like 10 ideas or something. And they might say, okay, today we're going to focus on, working on these 4 of them, working in 4 pairs of people. And, the rest will still be up on the board and the group can revisit the rest of them tomorrow. They might also get some ideas from the report out, hearing other groups. Oh, wait, that made me think of another thing that fits in our area. So there will be lots of opportunities to capture ideas that come up either, during the brainstorming, during the report out, and so on, or new ideas tomorrow.
All right, good. Thanks.
I was just also going to add that when we have the technical breakout session, there's also the possibility of creating new groups. If there's a group we've never thought of and it just emerges that there's something that's particularly interesting and exciting, we can put that together. So we have more flexibility when in our last breakout session, which is the technical session.
I just want to add, especially if you're like one of those folks who are like, well, I have interest in this group or that group, and you can only obviously go to one this morning unless somebody has a real big breakthrough they want to announce for all of us. Then you can put some of your thoughts for the other group that you might like to attend on the whiteboard, just as a sort of a placeholder to let people know for the group that you're not attending today, like just to give people a heads up of like in that group that, oh yeah, this person is probably going to come with us tomorrow and throw some of these ideas out.